So lesson 9.6, we're going to be analyzing solutions to quadratic equations. So in lesson 9.5, we introduced the quadratic formula and used it to solve for these quadratic equations. So today's big idea is the value of the discriminant, which is b squared minus 4ac. That was a piece of the quadratic formula. Of one of these equations in this form, it can tell you whether the equation has 0, 1, or 2 real solutions. So we already saw this in the last section, but now we're going to specifically start to analyze it. So first things first, we need to remember what the quadratic formula looks like. So it says x equals negative b plus or minus the square root of, and then here's the discriminant, b squared minus 4ac. And then all of that was over 2a. So let's make sure we know that this right here is the discriminant. And the reason it is because what the discriminant is it discriminates among the various possible number of real number solutions to a specific equation, so it is called the discriminant. So whenever we look at this and we ran through these equations, we didn't sit and analyze the number that we got inside the square root, but we did figure out at the end if there was 2 solutions, 1 solution, or no solution. But we never brought it back and specifically analyzed it according to the discriminant. And this will actually tell you whether there's 1 or 2 or 0. And so here's the property. If all of this is true, so this is just some math lingo. So basically you have the equation in this form. A, B, and C are real numbers, so they're not imaginary numbers, which we haven't even talked about. And A can't equal 0 because if you put 0 in for A, it takes away the x squared. And now you just have bx plus c, and that's a line. So the x squared is what makes this curve. And so we need a to be a number that's not 0, so it stays there. But if that's all true, here's how we analyze the discriminant. B squared minus 4ac. If it's greater than 0, so basically if it's a positive number, the equation has 2 solutions. And the reason is because you're taking the square root of a positive number, and the square root can always be a positive or a negative. So for instance, the square root of 100 can equal 10 and negative 10. And so when you get a positive number in here and you square root, there's 2 possible answers, and so it creates 2 solutions. Now when this equals 0, so a 0 on the dot, there's exactly 1 solution. So think about why that's true. It's because when you take the square root of 0, you just get 0. And so you end up doing a plus 0 and a minus 0, but that doesn't change the answer. So if you end up with a 0 inside there, you only have 1 solution. And if this becomes less than 0, so basically a negative number, the equation has no real solutions, because if you try and take the square root of a negative, it's impossible. There is no solution because no number times itself can create a negative number. Whether it starts as a negative or starts as a positive, if you multiply by itself, you're going to get a positive because 2 negatives make a positive. So basically, if we wanted to just analyze an equation and say how many solutions are there, we just need to look at what's called the discriminant. So if we slide to example number 1, you've got this equation. It's not in standard form yet. What's the value of the discriminant? So before you can actually do anything with that, we need to actually put this in standard form. Okay, so let's throw this into standard form. So first thing I'm going to do, and you can see this was already on here, is you need to add to standard form. Remember, means that all of this is equal to 0. So this is going to cancel, leaving you 0. And now we've got everything that we need on this side. So what we're going to have is we're going to have negative 3x squared minus 7x. And now we had a negative 4, we're adding 2, and so we're going to get a negative 2, so minus 2. So here's the standard form. Of course, it equals 0, but this is going to be our A, our B, and our C. So let's actually write this out. So A equals negative 3, B equals negative 7, and C equals negative 2. And so instead of going back to the entire equation here, the entire quadratic formula, if we're just answering the question, how many times will this cross the x-axis, or how many times is this true, how many solutions are there, all we have to do is go back to the discriminant. So we don't need the whole thing. We don't have to solve the whole thing. We just need to go back to the part that's inside parentheses, which is b squared minus 4ac. This tells us how many times it's going to hit the x-axis. Now let's go back. You might be thinking, well, we were just talking about how many solutions there were. What does that have to do with crossing the x-axis? So if you look at this equation, you're plugging numbers in for x, and we want to know what numbers do we plug in for x to create a 0. Well, you could substitute, instead of 0 over here, you could say f of x, which we also know is y. So y is equaling this whole equation. If you're plugging this into your calculator, it would say y equals this whole thing. And we want to know when it specifically equals 0, which means when y is 0. And if you think about a graph, y is positive up here and y is negative down here. Y is 0 everywhere on the x-axis. So if one of these parabolas looks like this, it's going to equal 0 for y in 2 spots. So this equation, could have 2 solutions if it equals 0 for 2 different numbers. It could hit the y-axis once, like this, and that means the discriminant was equal to 0, so I'm going to have one solution. Or you could have a parabola that never hits it at all, and that's what no solution is going to look like. It's never going to hit the x-axis, which means y is never going to actually equal 0. And if you think about all the y values here, all of these are going to be negative y values. And you could have one up here. It's going to have all positive y values. But if it's ever going to have a value of 0 for y, that means it's going to hit the x-axis, which is an x-intercept. So going back to the equation that we're on here, we're going to plug in. So we've got b squared. I'm going to go ahead and put this in parentheses so that we remember when we square this, it has to be a positive. We've said this many times, but if you plug in -7 without parentheses and square it, it's going to tell you the answer is -49 in your calculator because it's just squaring the 7 and leaving the negative out front. So if you wanted to square it properly, if you have to plug this in your calculator to get the answer, which you shouldn't have to, but if you do, you need to make sure you put those parentheses around it so when it squares it, it gets you a positive number. -7 times -7 is a positive 49. So before we get there, let's go ahead and fill the rest in. So 4 times a, which is -3, times c, which is -2. So let's run this out. You could put this all in your calculator at once too and get the answer. But when we square this, that's 49. Now 4 times 3, that's 12, times 2 is 24. Now there's 2 negatives here, so that's going to make a positive 24, and 49 minus 24 is 25. So the discriminant is equal to 25. So how many times will the graph cross the x-axis? Which one of these will it look like? So if I go back up to my properties, if we have a positive number, if the value of the discriminant is more than 0, so positive, there's going to be 2 real solutions. So how many times will this cross the x-axis? 2 times. Or you could say 2 solutions. Because the discriminant is positive. So if we put this on a graph, which let's go ahead and take a look. I've already got it entered here. If we put this equation in, -3x squared minus 7x minus 2, and we graph it, it should cross the x-axis twice. And it does. And so, of course, you could plug the whole thing in. You could go take a look at it. If you didn't have a calculator, you could go ahead and make an XY chart, and you could plot this, and you could start to figure out how many solutions there are. But the discriminant is always going to be the telltale sign. And again, the reason is because we were going to get a 25. And so inside parentheses here, we were going to get a 25. So it was going to say the square root of 25, which, remember, can be positive or negative. So it would have been whatever value is here for -b plus 5 or minus 5, because the square root of 25 could be either one, positive or -25. So that's why it produces 2 solutions. Okay, so there's your first example. We got a positive number. There's 2 solutions. So on the graph, it's going to look like this, a different spot on the graph, but it's going to cross that x-axis twice. So let's take a look at a different one. So example number 2, we need to put this in standard form first before we can analyze anything. So in order to do that, I need a 0 over here. So I need to add 4 to both sides. So I'm going to get a 0 on this side. Now, I can't combine it with x squared or 4x because it's not a like term. It's just going to tag on the end. So this equation is going to say x squared plus 4x and not minus 4 because I added 4 to get rid of it. So it's going to say plus 4 and it's going to equal 0. Or again, this could be f of x or this could be y. But we want to know specifically when does it equal 0. And that's telling us what the x-intercepts are. So what's the value of the discriminant? So first of all, we need our a, our b, and our c. So right from here, now there's always confusion. Sometimes people want to put 0 or they actually want to write x. We're just looking at the coefficient, what comes before x. Because up here, right, when we found a, we didn't put the x squared in our answer for a. It was just the -3, just the coefficient. So the coefficient here is just a 1. We just don't write it, but there's a 1 there. So a is 1, b is +4, and c is +4. So if I'm going to find the value of the discriminant, which again is -b squared minus 4ac, I think I said -b squared, I'm sorry, just b squared minus 4ac. I'm going to go ahead and put 4 in, so it's 4 squared minus 4 times 1 times 4. So if I ran this out, you end up getting 16 minus 4 times 1 times 4 is also 16. And so it's 0. How many times will this cross the x-axis? Going back to my properties, when the discriminant equals 0, the equation has one real solution because the square root of 0 is 0. There's only one answer. So how many times will this cross the x-axis? There's one solution because the discriminant is 0. And get used to writing that word. And let's take a look at this one. What is this going to look like? If we went back up to here, it should look like this one. Okay, it should hit one time. And so we're going to put our standard form equation into the y equals. I'm going to leave the other one on the graph so we can kind of look at them all together. So we have x squared plus 4x plus 4. If I put this on the graph, you can see there's only one x-intercept. There's only one solution for when this equals 0, and it's right here. Appears to be -2. All right, and then the last example we need to look at is what happens when there are no solutions. What is this going to look like? So if we go to example number 3 on the back, first things first, let's put it in standard form. So I'm going to get rid of this 9, so I'm going to -9. There's nothing to combine it with, and so it's going to be a -9 on that side. Now I want to put this in order. Okay, so I'm going to put my x squared first. It's -7x squared. This is a positive 9x, so plus 9x. And now I minus 9 to get rid of it, so it's going to be a -9 on this side. All right, so I want to know, when does this equal 0? So I need my a, my b, and my c. My a is -7, my b is +9, and my c is -9. And so I have b squared minus 4ac. I have 9 squared minus 4 times -7 times -9. So what happens here? So 9 squared is 81. Now I need to multiply all of these. So if I just go out here, 4 times -7 times -9. I get 252. And that should be positive because I left this minus here, so this didn't count as a -4 because I'm bringing the minus down. And so I had a negative and a negative that made a positive 252. If you had done it all together, you would have got a negative, and then you would have just wrote minus because you got a negative, but that's a different way to approach it. So when I subtract these, I'm going to get -171. So I'm going to get a negative number. So according to our properties, how many times will this cross the x-axis? None. There's no solutions. Oops, no solutions. Because the discriminant is negative. And again, the reason is because this would have been inside your square root, and you're trying to take the square root of a negative number, which is impossible because any number squared becomes a positive. So there's no solution here. And if we go ahead and add this to our graphs, going back to standard form, so negative 7x squared plus 9x minus 9, and we graph it. You can see it comes in right here and it never hits that x-axis. So again, when y is 0, here's y being 0, this is the x-axis, but when y is 0, there's no solution because this function never actually hits it.